Hey, welcome to The Explainer. Today we're going to decode a concept that's absolutely fundamental to networking, but can be a little confusing, the subnet ID.
Here's our game plan. We're going to start with what an IP address really is, dig into how the math works, and then wrap up by looking at why this is so critical in the real world.
All right, let's jump right in with our first section.
So you see an IP address like this all the time, right? But what does it really mean? Well, it turns out it's not just one piece of information, it's actually two, cleverly disguised as one.
Think of it like a mailing address. Every single IP address has a network part, which is like the street name. It tells you what neighborhood you're in. And it has a host part, which is like the house number. It pinpoints one specific device on that street.
Okay, so if an IP address has two parts, how does a computer know where the street name ends and the house number begins? Well, that brings us to the hero of our story, the subnet mask.
The subnet mask is basically a special 32-bit number that acts like a stencil or a filter. Its whole job is to tell a computer, hey, this part of the IP is the network, and this other part is the specific device.
Now, writing out that whole number is kind of clunky. So these days, you'll almost always see it written in what's called CIDR notation. That's the /24 we saw earlier. It's just a super simple shorthand that tells you exactly how many bits are for the network. That's it.
And this table really shows you how that works. A /8 means the first 8 bits are for the network, a /16, the first 16. But let's focus on /24, because you see that one everywhere, especially on home networks. That /24 literally just means the first 24 bits are locked in for the network, which translates to 255.255.255.0.
To really get how this mask works its magic, we have to stop thinking like humans and start thinking like a computer. And that means we have to talk about binary.
You see, for a computer, a number like 192 isn't 192. Not at all. It's just a pattern of ones and zeros, of on and off switches.
So how does it get from binary to 192? It's actually simple addition. Each of the 8 bits in that section has a place value, 128, 64, 32, and so on. A computer just looks for the ones and adds up their values. So in this case, you've got a 1 in the 128 spot and a 1 in the 64 spot. Add them up, and what do you get? 192. Simple as that.
So if we apply that same logic to every part of our IP address, we get this big long string of 32 ones and zeros. It looks a little intimidating, I know. But remember, it's just 4 groups of those 8-bit numbers side by side.
And now look what happens when we convert our /24 subnet mask to binary. It becomes so clear. You get 24 ones in a row, followed by 8 zeros. The ones literally mask the network part of the address, and the zeros point to the host part. It's a perfect visual.
Okay, we've got the IP in binary, we've got the mask in binary, now we're ready for the main event. Actually calculating that subnet ID. And you know what? It's really just a 3-step process. We've already done the hard part, which is converting everything to binary. The next part is even easier.
Okay, so first, let's just put our IP address in binary up on the screen.
Next, we take that subnet mask, also in binary, and we line it up right underneath it. And here's where the magic happens. It's so simple. You just look at the mask. Wherever you see a 0 in the mask, you changed a bit above it in the IP address to a 0. The network bits, where the mask has ones, they stay exactly the same. And what you're left with, that's your subnet ID.
And when we convert that final binary number back into plain old decimal, we get 192.168.1.0. That right there, that's the official name, the street name for this entire network.
So we've gone through all this math, but who cares, right? Why does this even matter? Well, that's what our last section is all about. This is the real world stuff.
This subnet ID is absolutely crucial for a few big reasons. First, it's what routers use to build their maps of the internet. They don't care about your specific laptop. They care about what network it's on. Second, it's huge for security. You can write a single firewall rule that says, block everything from the 192.168.1.0 network. Super efficient. And that's also why the subnet ID itself is a special reserved address. You can't assign it to a computer because it's not a house number, it's the name of the whole street.
This quote just nails it, right?
Instead of having to list out every single device on your network, you can just say, hey, we're the 192.168.1.0 network. It's a powerful shorthand for managing huge groups of computers.
It's just wild to think about, isn't it? This one super simple rule, using ones and zeros to draw a line between network and host, is one of the fundamental building blocks that makes the entire global internet work. Trillions of packets of data find their way every second because of this simple binary math.